Thank you for joining me on exercise 3D. I'm going to be looking at part C, and it's broken up into 3 parts, but part 1 will take most of the working. Find the values of the given parameter for which the equation, which is 2s plus 1 x squared, is equal to s 3x minus 1. And we want it to have 2 distinct real roots. Now, 2 distinct real roots is saying, therefore, the discriminant has to be a positive value. So that's really where we're not asked to solve it, we just want to know what is s so that we get a b squared minus 4ac greater than 0. They could be asking this as being a quadratic equation and a straight line, where the straight line is s 3x minus 1, the parabola is 2s plus 1x squared, and where they cross twice. So they could ask you that question. It's the same type of question. Watch out for that, where you just let each equation equal each other. So you let 2s plus 1, you let that parabola equal the line, and that's what we were starting with. And bring everything to one side. So this is a x squared minus, and I'll bring that over to be 3s x. That's minus s, so bring that across to be plus s. So I've expanded. I've said this is the value for a, this is the value for b, this is the value for c. So b squared minus 4ac is greater than 0 to be 2 distinct roots. So 3s squared minus 4 times 2s plus 1 times s has got to be greater than 0. So let's look at 9s squared minus 8s plus 4 times s. So 9s squared minus, let's just work this out to be 8s squared plus 4s. So 9s squared take away 8s squared take away 4s, just removing brackets. We've got s squared take away 4s greater than 0. Now that's s minus 4 greater than 0. It's like a quadratic, where you've got the quadratic crosses at 0, where s is 0, s is 4, and it's a quadratic. And where is that quadratic? Above the x-axis. So where is that quadratic above the x-axis? It's above the x-axis when s is less than 0 or when s is greater than 4. And that's part 1. Now, if the same question had have said one real repeated root, part 2, well, one real repeated root is saying that the discriminant is actually equal to 0. So in this situation, we'd have an equals 0, and therefore it has one repeated root when s equals 0 or when s equals 4. And it's using the same working as part 1. Part 3, if it's got no real roots, it means that the parabola and the line miss each other altogether. How do I do this? Miss each other altogether. Looks horizontal, doesn't it? Never mind. And that happens when b squared minus 4ac is less than 0, and that's going to happen when s is greater than 0, between, you see, between. So actually I'm going to say when s is between 0 and 4, you see that parabola is underneath. So the values for b squared minus 4 is negative when it's under the x-axis. Well, I hope this has helped. Until next time, stay happy.